In this lesson, we're going to be using product to sum formulas or sum to product formulas. All right, so on your formula sheets right here, bottom right-hand side of the first page, you'll see sum to product, and you'll see product to sum, depending upon what we're asked to use. Okay, bottom right-hand side, those two sets. So just notice the structure. When it says sum to product, here's a sum of sine and sine, and that converts to a product written this way. Notice there's no pluses or minuses except for like up here in the angles and the numerators. So the difference of sine goes to the product of cosine and sine with this additional requirement. The sum of cosine goes to this product, and this difference goes to that product. So these are sum, and I know you're thinking that's a minus, but remember we could really write it as the sum of a negative, plus minus, and here we could do plus minus. So really these can all be considered sum, and the answers are all products, which you multiply. Okay, and the other way, the other side of that is, okay, take a product of sine and sine of two different angles, and you're going to get a difference, okay, or actually a sum if you thought of that being plus minus. Okay, the product to sum, and a product here to a sum here, plus minus again. So this is our focus. This is where I'm going to be grabbing our formulas from today. Okay. All right, and this is textbook page 530. So we're asked, and these are the specific problems from those sections. This might be the one where I changed the problem up a little bit maybe. So if my problem isn't exactly the same as these problems, then know that it was purposely meant to be. And I think that actually this is problem 78 in the textbook. All right, it says use the product to sum formulas to write the product, this product, as a sum or difference. All right, so product to sum. So I see sine times cosine. So product to sum. So I see sine times cosine, so it must be this formula right here. Notice that we want to identify u and v. And then that's equivalent to 1/2. We have a big bracket here. And then we have sine of u plus v plus sine of u minus v. So it's important to identify what's u and v. So keep this formula handy because this is what we're going to be working off of. Okay, so it must be that pi over 3 is u and v is also another pi over 3. Okay, that's fine. Notice the 6 out front. Okay, we can just kind of like put that on hold. The 6 doesn't really have anything to do with the formula. It's just kind of out front. So we've got 6 times, and then we want to do this big bracket here. So now that we've moved this out of the way, we can focus on this product. Well, sine times cosine tells us that we begin with a half. So I will multiply 1/2 times 6, getting 3. And there actually is another bracket there. And if it's sine times cosine, thank gosh we have our formula sheets. Okay, we've got sine of u plus v, and then plus sine of u minus v. So u and v happen to be the same thing, so pi over 3 plus a pi over 3 here, and this is pi over 3 minus pi over 3. Okay, so I'm going to go ahead and multiply 6 times 1/2, get 3, and then I will go inside here and have sine of, well, that's 2 pi over 3 plus, and this would be sine of 0. Now, keep in mind that we can find these values. We do know what sine of 2 pi over 3 is from the unit circle. We do know what sine of 0 is, but they're not asking me to simplify and get an answer. They're saying use the product to sum formulas to write this product as a sum or a difference. So it almost feels like it's unfinished, but we're just going to go ahead and say this is our answer, because they're not looking for a value. They're just looking for a rewrite. Okay, for 78, write the product as a sum or difference. It's sine times sine. We've got the 3 out front, so we're really going to multiply 3 times the 1/2. Okay, so I'm looking for sine times sine. Oops, wrong sheet. Here's sine and sine. So inside here, I see that we changed to cosine of a difference minus cosine of a sum. So cosine of u minus v, this is u and this is v. Cosine of a difference minus cosine of a sum. So u minus v is 2 alpha minus 3 alpha. And then 2 alpha plus 3 alpha. All right, so we'll clean this up. This is just going to be 3 halves out front, and I'll keep the bracket. So this is cosine of negative theta, or alpha, minus cosine of 5 alpha. Parentheses or not, it doesn't matter. All right, one thing that's not major, but just to point out, if you were to check this answer in the back of the book, cosine of negative alpha is actually equivalent to cosine of alpha. Now that just works for cosine. I didn't say it works for sine, but it does work for cosine. I'm looking on the formula sheet. I thought we had that somewhere, but yeah, we do. Okay, let's look at this. Cosine of negative alpha. Cosine of negative u is equal to cosine of positive u. And that's not true for all the other trig functions. This is called a negative angle identity. So probably should clean that up. And then 5 alpha here. Bracket. And we're done. All right, let's go the other way for these next 2 examples. Let's use the sum or difference to product formulas to write the sum or difference as a product. Okay, problem 85. So this is a difference, and we want to go back to a product. So we're using the sum to product formulas. So I've got 2 sine functions with a minus. So that would be the second formula here. So let's identify u and v. So this is u, the whole thing is u, and then this whole difference is v. Okay, I'm gonna put an equals down here. So I'm right here. So out front, I'm gonna have a 2, and then I have cosine of the sum of u and v divided by 2 times the sine of u minus v over 2. So I'm just gonna use this structure right here. Keeping that handy. I'm gonna do kind of a big parenthesis, and in my fraction bar here, or under my fraction bar, I'm gonna put a 2 times sine, big quantity here, sine, yeah, fraction bar with a 2. So in the formula, it has me on top here do what? U plus v. So u is alpha plus beta plus alpha minus beta. Over here, it has u minus v. So u is alpha plus beta minus, but you have to be mindful of another set of parentheses because you have more than one term. So this is alpha minus beta. Let's do a cleanup. Okay, in this numerator, the betas will cancel, and I'm left with 2 alpha over 2. So it looks like I didn't need that much space. Sine, probably don't need this much space either. Let's distribute that negative inside. So I'm going to have alpha plus beta minus alpha plus beta once you distribute in. So now this time the alphas cancel and you're left with 2 beta. I would clean that up. So 2 cosine of 1 alpha times sine of 1 beta. So we took a difference and we rewrote it as a product. This is your final answer. So maybe you guys try this one. Pause the video, and then when you get an answer, turn it back on and kind of see how you did. So it looks like it's a difference of cosine. So it looks like it's this last formula here. So let's identify u and v. All of that is u and all of that is v. So starts out in the formula -2 times the sine, big parenthesis here, divided by 2, and then times the sine here. Big parentheses divided by 2. So this numerator in the formula is u plus v. So theta plus pi over 2 plus, I don't need a parenthesis around v because I'm adding. I don't have to distribute a negative in. Theta minus pi over 2. Over here, though, I have to do u minus v. So it's theta plus pi over 2. You don't need parentheses up front. It's just when you fall behind the subtraction sign. Minus theta minus pi over 2. Notice the pi over 2's will cancel. You're left with 2 theta over 2. And 2 theta over 2 would just be theta. Okay, here you want to make sure and distribute that negative first. So I'm going to go up above here. And negative into a negative is a positive. So the thetas will cancel and you're left with a half pi and a half pi, which is a whole pi. And then a whole pi divided by this 2 is sines up front, sine over pi over 2. Okay, now you know sine of pi over 2 is 1, but that just, you kind of lose the effect of using the sum to product formulas. So if you check the back of the book, it's likely that it's going to leave it with sine pi over 2 as opposed to changing that to 1 and just having an answer of -2 sine theta. Okay, one last problem. Now this is number 100 in this section, 6.5. It says use the figure. Notice it's 2 right triangles. Use the figure and trigonometric identities to find the exact value of the trig function in 2 ways. All right, let's label this triangle because over here we have the product cosine alpha times sine beta. Let me get my picture here. Okay, in this larger right triangle, let's go ahead and indicate it is a right triangle. Okay, this leg length is 12 and this leg length given is 5. And I'm trying to remember what was given over here. This smaller right triangle has a right angle here. And I think this 4 was given, the distance from here to here. And I want to say this 5 was given here. All right. And then we also had to know that this angle in this larger right triangle, just from here to here, was our alpha angle. And then in this smaller right triangle, this angle right here was our beta angle. So beta's in the smaller triangle and alpha's in the larger triangle, okay? And then we had to apply Pythagorean Theorem so that we could find some missing side lengths. So in the small right triangle, notice this leg length is 4, the hypotenuse is 5, so that means that this distance is 3. Okay, likewise in the larger right triangle right here, the 2 leg lengths were 5 and 12, so Pythagorean theorem results in a hypotenuse of 13. So the whole distance from here to here is 13. This portion of that 13 is 4. All right, it says use the figure and trig identities to find the exact value in 2 ways. Well, we're going to do the first way the first way we're going to do is the easiest way. If it wants me to find cosine of alpha times sine of beta, I'm just going to find cosine of alpha and sine of beta and multiply. So alpha is here in this triangle. Cosine is adjacent over hypotenuse, so 12/13. And sine of beta, here's the beta triangle. Sine of beta is opposite over hypotenuse, 3/5. So my answer is simply 36 over 65. Okay, the second way, that's going to be to use one of the formulas in this lesson. We're going to be using the formula that goes from product to sum. So let's find the product cosine and sine, where alpha and beta are u and v. So I'm looking on, we're doing cosine and sine. Cosine and sine is down here. So we're going to actually use this formula to find the same answer. So let's apply this formula to what we have. So U and V. That formula starts out with a half. I got a bracket. Sine of, and in parentheses, it's U plus V, or alpha plus beta, minus sine of alpha minus beta. Okay. Problem is, we don't know what the measures are for, the angle measures are for alpha and beta. Okay, so we've got some work to do here. So we use the product to sum, but now we have another issue. So we got a half. Now what we're going to have to do is use the sum and difference formulas for sine. So I've got 1/2 times a big bracket. So let's go back to our formula sheet. Let's find the sum of sine formula, bottom left. So that's sine of alpha cosine of beta plus cosine of alpha sine of beta. So all of this is from the difference, or the sum formula for sine. Minus, now do another parenthesis. Okay, now we're going to have to do the difference of sine for this. And then close your bracket. Sorry about that. Oh, dear goodness. Before I start plugging things in, let's just see if anything cleans up and cancels. When you distribute this negative, okay, I hope you see that this term, once it's negative, will cancel with that term. When you distribute that negative in here, that makes that a plus, and this term is exactly equal to that term right there. I think before I start plugging in numbers, I'm going to see if there's anything I can clean up, and I just did. So a lot of writing, but let me go back and distribute that negative. Remember, that's a whole group, so you just put the negative in front of it. This is a whole group term made up of factors, so that's plus cosine alpha sine beta. Okay, now we see that these two terms are identical. They're opposites, I guess. They cancel. Now, looking right here, this is one and then another one of the same, so that's two of these terms. So 2 of these times a half would just make 1. So all of this, when I collect and multiply by half, is just going to give me, oh my gosh, it's going to give me cosine alpha times sine beta. That's exactly what the original problem was. So cosine alpha was 12/13 and sine beta was 3/5. Huh. I mean, we should get the same answer. I mean, we did everything right. But it's funny how we just ended up with the same expression that we started with up there. All right, that's it.